Now it's time to begin our discussion of the trigonometric functions. And I like to begin talking about angles and their measures to kind of set the stage for trigonometry, since a trigonometric function is actually the function of an angle. Okay, so let's look at the figures that we have before us. The one on the left is a figure showing basically an angle is, comprised of two rays meeting at a vertex. And if you designate how you're measuring an angle, every angle has an initial side, and that's the side you measure from, and a terminal side, which is the side you measure to. And then you can give the direction in which you intend to measure the angle. So I can go this way, or I could start with the same initial side and go this direction and measure the angle differently, but have the same starting point and terminating point. Okay, so given that we have an initial side, a vertex, and a terminal side, we're going to calibrate our thinking about angles with what we refer to as the standard position of an angle. So using the coordinate plane as a guide, the standard position of an angle means that your vertex is at 0, 0. So the vertex is always at the origin. Okay, and it means that your initial side lies on the positive x-axis, like so. And then depending upon the size of your angle and the direction in which you intend to measure it, the terminal side is where you land. Okay, so again, standard position of an angle means that your initial side is on the positive x-axis, your vertex is at the origin, and then where you terminate is still referred to as your terminal side. Okay. Now in the figure also to the left, you see this reference to coterminal angles. Angles that share the same initial and terminal sides are referred to as coterminal. So for example, again here, the measuring in the direction of the black arrow is a different size angle than measuring with the green arrow, but they share the same vertex, initial side and terminal side, so they are considered coterminal. There are a couple of angle measures that we are particularly interested in. One is degrees and the other is radians. Degrees is by and large the most familiar measure to us, as we know how to make a circle, and we are accustomed to thinking of, and you can see in the figure above, the complete circle is 360 degrees. So it makes sense to say that an angle of measure 1 degree is obtained by carving out 1/360th of a complete counterclockwise revolution. Now, it actually could be clockwise also, but from standard position, what you're saying is this: if I go all the way around from the initial side and I terminate on my initial side, that's 360 degrees. If I start on the initial side and I terminate a quarter of the way around a circle, that's 90 degrees. If I go around 360 degrees back to the initial side and decide to go 180 more, that's 540 degrees. The other thing I'd like to comment on is this: if I am measuring in the counterclockwise direction, we call those positive angles. And later we'll develop why that's important, but for right now let's accept that this is the standard way we do these. And if I measure in the clockwise direction, we might measure out the same number of degrees, but we call these negative angles. Okay, and now for example, in the world of the idea of coterminal angles, if I have positive 90 degrees in this second figure here, if I start from the initial side and measure to the same terminal side, I would also call this negative 270 degrees. Okay? All right, and you can see some more examples of coterminal angles in the figure below. And the fact that you can wrap around and create angles larger than 360 degrees just by continuing to go in a circular wrapping function pattern. Okay? And I can measure both positively and negatively. Okay, and so again, you can have two positive angles be coterminal. For example, if I went all the way back around here, this would be 360 plus the existing 60, and that would be coterminal to 60 degrees. You know, or I can have a coterminal pairing with one positive angle and one negative angle. Okay. I'd like to define radian measure in a more formal way than people are accustomed to thinking about, because most of the time students come into a class like this and you've memorized conversion factors, and I actually want to derive those with you. Okay, so if you have a central angle theta, that means the vertex of your angle is the center of a circle with radius r. And you are subtending the angle with an arc of length s. And in this scenario, the definition says that theta in radian measure is the length of the arc divided by the radius. So if basically the radius were in inches and the arc length's in inches, the units would cancel. And so we think of radian measure, you know, as a unitless number. Now let me give you an example. If I were to take not a good circle picture, is it? Okay, so if I were to take angle, central angle, and let's say I want to make this angle 180 degrees start to finish, I would know that my angle is subtended by an arc whose length is half the total circumference of the circle. And if the circle's radius were generically r, then the arc length is pi r. Okay, so with the definition of radian measure, we would say that 180 degrees in radians, by definition, must be the length of the arc divided by the radius of the circle, or in this case the number pi. So the conversion factors that you may have once upon a time memorized are actually derived from the definition of radian measure. And here you see a few common relationships. Yes, I think it is most important that you remember 180 degrees is pi radians. And then you can take that and run with it. That would mean 1 degree is 1/180th of the number pi. It would mean 1 radian is 180 divided by pi degrees. It means things like the following. If 180 degrees equals pi, then if I divide both sides by 2, 90 degrees would have to be half of the number pi. And you can see a little chart made for you below with a lot of these, you know, conversions, but make them make sense to you and go back to your one key statement here to help you out with all these conversions.